Hello ladies and gentlemen, what we're going to talk about today is ionic bonding. So without further ado, let's go ahead and get started. So what you should have recently watched was my ions video over how ions form. So one thing that I went over in that video is how to draw electron dot structures. So if you need to go back and watch that video because you've forgotten or you missed it, you can go back and watch that now. But otherwise we're going to go ahead and I'm going to show you how to draw the electron dot structure for some elements. So this first one, it says draw the electron dot structure for nitrogen. So whenever you draw an electron dot structure, the first thing you do is you start with the symbol for that element. So I look on my periodic table, find nitrogen, its symbol is N. So I put N. Then I'm going to look, remember to draw an electron dot structure, what you have to do is you have to look at what column it's in. For the representative elements, which are the groups 1, 2, and then 3, 4, 5, 6, and 7A. So those are the 2 columns all the way to the left on the periodic table, and then the 6 columns all the way to the right. Those are called the group A elements. And the group number that they are in tells you the number of valence electrons it has. So if you find nitrogen, find what column it's in column 5A. So what that means is it has 5 valence electrons. So then all that I'm going to do is I'm going to take dots and I'm going to put that around the nitrogen until I get 5 dots. So it should look something like this. Now these dots could be like this dot right here, could be on the other side. It really doesn't matter as long as you have 5 dots around it. Technically the right way to do it would be to have no more than 2 dots on each side of the nitrogen. So you've got the right or the left, right, top, and bottom. Basically what you do is you start on one side of the nitrogen and you put 1 dot until you have 1 dot on each side. Then if you have more than 4 dots, you continue adding them in. But really as long as you have 5 dots, you should be good. Next thing that we talked about is the equations for when electrons gain and lose electrons. This is actually called ionization, okay, when atoms get ionized. So what we're going to look at is what the equation looks like for the loss or gain of electrons for nitrogen. So in previous chapters, what we've talked about is something called the octet rule. The octet rule means that atoms either want to get to 8 valence electrons or they want to lose their valence electrons to get to 0. So because nitrogen, we just talked about, has 5 valence electrons, it's easier for that nitrogen to get to 8 by gaining 3 electrons than by losing all 5 of its valence electrons and getting to 0. So what you'll find is that atoms that have 5, 6, or 7 valence electrons, they want to gain electrons to get to 8. And atoms that have 3, 2, or 1 valence electrons, they want to lose those electrons so they can get to 0. Now the ones that are right in the middle, the 4 valence electrons, they can kind of go either way, and it depends. But for nitrogen, again, it has 5 valence electrons, so it's going to want to gain 3 electrons to get to 8 valence electrons. So what would happen is we'd have our nitrogen atom, okay? It's going to gain 3 electrons, and what happens is, remember, when atoms gain electrons, they become negatively charged. So this nitrogen would now have a -3 charge on it, and that's because it has 3 more electrons than it does protons, and electrons are negatively charged, so that gives it that -3 charge. So now we're going to start talking about some ionic bonding and what happens in ionic bonding. So ionic bonds form when atoms that want to meet or want to lose electrons meet atoms that want to gain them. Okay, so some atoms want to gain, some want to lose. So what we're going to do is we're going to start by looking at the EDS. I just abbreviated that for electron dot structure for sodium and chlorine. So here's sodium, here's chlorine. To draw the electron dot structure, you look on the periodic table, you find sodium. It's in column 1, which means it's going to have 1 valence electron. Then chlorine, it's in column 7, which means it's going to have 7 valence electrons, like this. So what I just talked about recently was that atoms that have 1, 2, or 3 valence electrons, they like to lose them. They like to get rid of them, right? Because it's easier for it to get to 0. 0 valence electrons, or 8 valence electrons, those both really mean the same thing, are stable for atoms. So sodium wants to get rid of this electron, and chlorine wants to gain. So because they both kind of like sodium giving its electron to chlorine would make them both happy, because sodium wants to lose one electron, chlorine wants to gain one electron. So what's going to happen is this: when this sodium and this chlorine get close together, this chlorine is going to like pluck this sodium away, or this electron away from sodium, so that then chlorine will have 8 electrons. It would now be happy, and sodium would have 0 valence electrons. It would then be happy. So what this does is this makes sodium a cation and chlorine an anion. And what I want you to remember is to try and tell the difference between the two of those. Cations are always positive, so I always come up with this. I say cations are positive, okay? Like a cat has a paw, so cations are positive, okay? So here's what we'd be left with. Because sodium lost an electron, it lost a negative charge. That means it's going to be positively charged now, or have a +1 charge. Chlorine, it gained an electron, which means it gained a negative charge, which means it's going to have a -1 charge. Now, the attraction between those two things, you've probably learned this a while ago, but positives and negatives do what? They attract. So the attraction between that cation and anion, that attraction is what forms an ionic bond. So there's really not something holding them together. It's what's called like an electrostatic force. Okay, so it's an attraction because their differences in charge move towards each other. So this attraction here is what creates that ionic bond. And this right here, this NaCl, is what's called a chemical formula. Okay, so we would write NaCl to represent this compound that's been formed, this ionic bond that's been formed. So again, I want you to notice that these have a positive and a negative charge on them. And what happens is when those two come together, they come together in a equal ratio. There's the same number of positives as there are negatives, and that's why this is a neutral compound. We don't write our charges on our substance. Okay, so you'll have to do this in some of your assignments. So this is kind of what you would do. So this would be the chemical formula for it, and you would draw that reaction by drawing kind of this happening. So let's look at 2 others. So in that instance that we just went over, sodium wanted to lose 1, chlorine wanted to gain 1. So that was like a perfect match, right? But what would happen if we had 2 atoms that didn't want to gain and lose the same number of electrons? So for instance, calcium and chlorine. So calcium now has 2 valence electrons. Chlorine has 7. So chlorine here only wants to gain 1 electron. And we have to have a balance of charge. So if chlorine were to gain that 1 electron, okay, it would be a -1 charge. But calcium would still have this 1 electron hanging out that it wants to give away. So calcium's not going to react with chlorine until it can find another element that's willing to take that other electron. So since calcium has an oxidation state or charge of +2, what that means is calcium wants to form a +2 charge, because when it loses both of its electrons, it's going to become a +2 charge. Chlorine, it has an oxidation state, or it wants to form charges of -1. So since that's the case, since calcium has 2 valence electrons and it wants to lose both of them, and chlorine only wants to take 1 of them, we need something else. And what we actually need is we need another chlorine. Because if calcium and chlorine are going to react, there's probably going to be some other chlorine ions, or excuse me, chlorine atoms floating around that would be able to react with calcium. So we're going to need another -1 charge. We're going to need another element that wants to form a -1 charge, which would be chlorine. So here's what's actually going to happen. We have our initial calcium atoms. Our initial calcium, again, it has a it has 2 valence electrons. So this, we have to bring in another chlorine atom, and again, chlorines have 7 valence electrons. So this electron from this calcium is going to get stolen away by this chlorine, and then this chlorine is going to take this electron. And now what you'll notice is all the atoms involved are happy. Okay, remember, atoms either want to have 0 or 8 valence electrons. Calcium would have now lost both of its electrons, so it's happy, and each chlorine would have gained 1, and so they're happy. These two have 8, this one has none. All 3 of them are involved are happy. So what this would give us is this would give us these charges. Okay, so we've got calcium now with a +2 charge. Okay. Chlorine's now with a -1 charge because calcium lost 2 electrons. It lost 2 negative charges, making it a +2. Each chlorine gained a negative charge, which makes them each -1. That would give us this formula. We would now have CaCl2, and that's because we have 2 chlorines now. And again, this is my chemical formula. Okay, this is the chemical formula for this kind of reaction that happened. And what this means is that we have a ratio of calcium to chlorine as 1:2. For every 1 calcium, I have 2 chlorines. And what this is called is a formula unit. Okay, so we call this here CaCl2, we call that a formula unit. So what I want you to notice about these atoms that react is, let's look at kind of the two that we went with. So I want you to maybe take a second or pause the video, and I want you to look at your periodic table and look for these elements that are involved. Look for sodium, look for chlorine, and look for calcium. Look at where they are. So look at those for a second. Again, you can pause the video, give you a second to look at it. But what I want you to notice is that ionic bonds always occur between a metal and a nonmetal. Sodium is a metal, chlorine is a nonmetal. Calcium is a metal, chlorine is a nonmetal. So you're always going to have ionic bonds happen between a metal, which is an element to the left side of that staircase on your periodic table, and then you have sodium, which is you have chlorine, which is an element on the right side of the staircase in that kind of upper right-hand corner. Those are the nonmetals. Now, here is a ionic structure or an ionic crystal. So this is actually what ionic compounds look like. Okay, they're not single sodiums and chlorines stuck together. They're typically large crystals, kind of like this. Now, I guess the crystals can be small, but if you were to zoom in like microscopically and look at sodium chloride, it would look something like this. And so each of these spheres represents a sodium ion or a chloride ion from our first example, and those are all held together by those positive and negative attractions. And what I want you to notice is, in this instance, chloride would represent the this green sphere. Sodium would represent, or excuse me, got that backwards. So chlorine would represent this green sphere, sodium this purple sphere, and so they would just be held together by that positive and negative attraction between these two particles. So that's kind of what holds this all together. Now, some of the properties of ionic compounds is that, first of all, most ionic compounds are crystalline solids at room temperature, meaning that if you had an ionic compound sitting out right now in the room, it would probably be solid. Next is that those ionic compounds generally have high melting points, meaning we have to really heat them up a lot if we want to get them to turn into a liquid. Sodium chloride, what I was just talking about, has a melting point of like 800 degrees Celsius. So really, really high melting point. Then the last thing is, when you take ionic compounds and dissolve them in water, they actually can conduct electricity. So that's a typical thing of a lot of ionic compounds, is they will conduct electricity if they're able to be dissolved. So I hope that you found this video interesting. If you have any questions, please let me know in class. And thanks for watching.